Lab 5, Analyzing Gravity. So for Lab 5, this was an independent project. We could choose our own, and our group chose to focus on one of the first but most fundamental concepts in the course, gravity. We wanted to observe the effect of the force of gravity on an object. In this case, we chose an expo marker. And the lab is only experimental, so we had no code, but we compared this to the real behavior of the object and the force of gravity. We compared it to a theoretical model using Newton's calculations and iterating it ourselves. And in summary, the results showed stark differences in both, most likely because of factors that weren't taken into account with the model. So the main concept we'll be using here are Newton's second law, so the net force, then using the net force, which is moment mass times acceleration, and using that to calculate velocity and then the position of the marker falling down. So in this case, we are assuming there are no effects on the x component of the object's position. It is being dropped vertically. We're ignoring all other forces, therefore the net force will be 0 in the x and z direction and only negative mg. G is that gravity constant. This will be the only net force acting in our model. So the method for the experimental data was we used a video of an expo marker being dropped. We recorded it, put it in tracker, set the offset origin and the axis to be where the marker was dropped, and then decided to choose a frame of 37 to 64, which is around 1-ish seconds, and use the length of the marker as our guide. So the data, specifically y position and time, was extracted from tracker. We ignored the x graph, and we made some adjustments, for example, shifting it also so it could start at 0 both the time and so the position could start at the origin. So we used some formulas and shifted all the data. And then these are the calculations we used to calculate the theoretical. So using the mass of the marker, and then acceleration, and then plugging into the velocity, we got a velocity of 0, negative 11, 0.5, 0 meters per second, which we then plugged into the position update formula to calculate what the trajectory of this marker should look like. And these were the results. So in the experiment, we can see that there's more of a curved motion, while theoretical is purely linear, and we can see these little two smaller curves here, which I will explain shortly. So both graphs do show decreasing trends, so we know that gravity is having a negative downwards effect or on the y component of our object. However, the first half of the experimental graph shows a curving shape instead of a linear relationship. The latter half of the experimental graph shows smaller curves. So why could this be? So these smaller curves could be because of the recoil. We didn't display the video, but essentially when the marker was dropped, it bounced a little, which was not accounted for in the model. And then some other things we can notice that it's curved. This could be the effect of drag. Drag was also not accounted for when we made our model, only the force of gravity. So this goes to show that it might seem simple theoretically, but there's more than gravity acting on this object. So neither recoil nor drag force accounted for. We also didn't account for X position. In the video, it did slightly move in the X position, like changing angles, which we chose to ignore. So that could have also had an effect on why our model looks so much different than our experimental. And then we could also have had some possible errors in the method. So the marker wasn't really dropped straight, it was dropped at an angle, and that could have been a reason for this discrepancy. Also, the manual tracking to track the position, we used the point mass tool in tracker, but obviously due to human error, there could be discrepancies in how it was done, but mostly this is a system error of not accounting for things like drag force or recoil. So here are some further questions that we decided to explore. So how could the experiment have had increased accuracy? So made it look more like the model. So using a ruler calibrator tool to ensure the object's not being dropped at an angle, like I mentioned earlier. And some possible thing, maybe try to avoid recoil. So in this case, a marker, due to the law of reciprocity, with Newton's third law, there was recoil. But maybe a surface like sand or something that would allow the object to just sink without the recoil could have had we could have had a more accurate looking graph. But another thing we should look at is how can we make our method more effective? How can the model look more like real life? So this would be taking into account the drag coefficient and the drag force, which we have done in previous labs. We're going to be plotting the changes in x position and attempting to see if there's a horizontal velocity of the object and what is causing it.